Good afternoon and welcome everyone. My name is Rigoberto Lara Guzman. I am the senior producer here at Data and Society, and I'm so excited to join this conversation and get this started. Data and Society is an independent nonprofit research and policy institute studying the social implications of data-centric technologies, automation, and artificial intelligence. We produce original research and regularly convene interdisciplinary thinkers to examine the implications of technology on the public interest. Today's webinar, we will discuss a new Data and Society primer by Samir, Passi, and Ranjit Singh, drawing on fieldwork in a computational biology laboratory, the Oversight Fallacy, why AI agents require more than humans in the loop, examines what effective oversight over automated processes requires in practice and what roadblocks get in the way. I'm pleased to introduce our moderator for today's discussion. Madeleine Claire Elish is the head of evaluations, responsible development, and innovation at Google Deepmind and a Data and Society alum. Madeleine, it's great to see you. Welcome back to Data and Society. The mic is all yours.
I am truly so glad to be here. Thank you for having me. So let's get started. AI agents have begun to move from speculative promise into everyday deployment. So-called agents can now translate high-level goals into plans and carry them out across connected digital environments. People who engineer such automated systems often promise that users will remain in control by designing a series of safeguards. Yet these safeguards only work when users can see enough of an agent's work to recognize that something has gone wrong. They must be able to intervene before its consequences cascade. We are joined today by the primer's authors, which Rico mentioned. Samir Passi is a social scientist and Data and Society affiliate, specializing in the socio-technical and organizational challenges of building and using AI. Samir has been working as an AI researcher at Microsoft for the past 5 years in a contractual position, focusing on advancing effective oversight and appropriate reliance on autonomous AI systems. Ranjit Singh is director of the AI on the Ground program at Data and Society, where his current research examines how AI is shaping scientific practice. I'm also delighted that we are joined today by Margaret Mitchell, chief ethics scientist at Hugging Face, whose work has truly helped shape research and practice around responsible AI. So I am really excited to get into a discussion with this amazing panel. But first, I want to hand to Samir to talk through some of the key concepts and vocabulary that's in use in the primer. So Samir, back to you.
Oh, sure. Thanks, Madeleine. And a big hello to everyone. So we thought that before we kind of dive into the challenges of overseeing AI agents and sort of what we can do about that, we think it's important to first explain a little bit about what these agents are and what are some of their key characteristics that might be highly relevant to today's discussion. Right? And we'll use all of this graphic to do exactly that we created. Now, I'm sure all of you have at this point used or heard about some large language model powered chatbot, right? ChatGPT was the first one, came out a few years ago. I've heard it like 10,000 times every day. There's more coming afterwards, like Claude, Gemini, Copilot. The list is endless. Right? You sort of ask them questions, you get answers. You, I don't know, want to write an essay, you tell them to write an essay, they write you an essay, right? Kind of simple. Now, AI agents, on the other hand, are a little bit different than the kind of chatbots we've gotten used to, right? And a key difference is that agents do things. That's right. They don't just answer questions, but they actually take actions in the real world on their own, on your behalf, to accomplish what you want to do. And agents are already out there doing all of that, right? I mean, there are agents today that can, I don't know, plan and book entire vacations for you, flight bookings, hotel reservations, you name it. There are agents writing complex production level code in tech companies. There are agents kind of calculating and giving medical treatments to patients. There are agents as customer service agents, loan underwriters, and so on. Like, the list is endless, right? But What's important here is that for all intent and purposes, you can treat an agent as sort of like a delegate of someone. Right? And as a delegate, an agent needs to do at least two things. Right? It needs to decide and it needs to act. And it's these two very things that really make agents unique to a lot of the AI systems we know for sure. First, agents decide. Right? What's shown here on the slide on the first three cards on the left. Right? You tell an agent what to do. It uses a large language model to kind of interpret what you're saying and decomposes that into what's usually called a plan. Plan is like a series of actions or steps that the agent outlines it will do to kind of accomplish your high-level goal. But this is far from a simple process, right? There are many paths to a solution. You have to pick the right one and know why. When you break problems into sub-problems, like you really need to have context, experience, expertise. You need to know how to make good assumptions, have informed opinion, right? All of that's extremely hard, even for humans. But agents seem to be doing that to a lesser or greater extent. It's all this taken together that we call in the primer delegated discretion. The fact that AI agents, by design, must assume, infer, and decide on our behalf. It's a very big characteristic of today's agents. And second, as I said, agents need to act. What's shown on the next two yellow cards here? Once the plan's in place, the agent sort of goes out in the world and executes the different steps in the plan to kind of accomplish what you wanted it to accomplish. And they can use web browsers. You know how we click on websites and fill out forms? They can do that. They can write files, execute code, talk to other agents. They can even sort of like make purchases on your behalf if you give them the right information. Right? Basically, think of anything you and I can do in the digital world, an agent can do that pretty much. And this is all what we call in the primer as delegated action. That the fact that AI agents, again, by design, take consequential real-world actions on our behalf. And the result is the final output or process, what you see on the right-hand side. Now, if agents did everything correctly, amazing, we would not be in this panel. You'll be like, yeah, problem solved. Let's sit back, relax, and let agents do everything. But reality is, unfortunately or fortunately, far from it. Right? Every day we hear news stories about agentic failures, right? Coding agents delete entire production code bases. Different servers keep going down since AI agents have started coding. We know of cybersecurity issues, the whole OpenAI fiasco recently about coding agents breaking out into hyperspace. There are many more failures, right? And we keep hearing about them every day. Agents are failing fast, they fail at scale, and they fail quite often, to be honest. As we explained in the primer, we need to understand these failures not really as problems to be solved. Of course, they're problems and we need to solve them. But we need to treat this failure as sort of natural outcomes of how agents work, right? Of what it means to act in the world. Each transformation that I just described to you, interpreting and kind of turning our goals into plans and then taking those plans and executing them in the real world, sort of created own conditions of failure, as you can imagine. On the deciding side, like agents can misinterpret what you said, they can make wrong assumptions or simply make unwanted trade-offs that you wouldn't. On the acting side, they can sort of fail to use the tool properly, not even invoke the right tool. They can lose track of tasks and context midway. Agents are known to do that. They're known to cut corners and even lie to users. And finally, it's agents somehow, and I see a lot in my work, simply go on tangents and do stuff that you don't even ask them to do. And then you're like, what just happened? Taken together, this problem is what I call the goal plan execution gap. That's what we describe in the primer. Sort of mismatches between how users describe goals to agents, how agents sort of interpret and plan for those goals, and how those plans really sort of perform in real-world execution. These gaps really create these moments of failure. And the gap exists, and it makes failures a very ordinary part of agentic systems. And as agents get better and better, such failures will reduce for sure, but they're not going to disappear, right? If anything, they're going to become even more harder to see and find, unless things get too late. So I know that was a lot, but we do have some of the conceptual grounding in place now. And with that, I want to pass it over to Ranjit, who can help us situate this theoretical concept in a more concrete real-world setting.
Thanks, Samir. I'm going to take the goal plan execution gap and make it concrete through a case from the fieldwork that we've been doing around the use of AI in the sciences. And we also, discuss this case in the primer itself. So the case comes from AI Science and the Future of Knowing, a project that I lead at Data and Society on how AI is changing scientific practice. It follows researchers who are deciding which parts of the scientific work can be delegated to AI systems and how to judge the work of those systems. And one of the sites that we have been following is a computational biology lab, which is developing a benchmark for coding agents. So what the team does is that it turns pieces of ordinary lab work into repeatable tasks, which allows them to compare agents under different testing conditions. They're asking whether an agent can complete a well-scoped research task in a way that a scientist would recognize as methodologically acceptable. So in this task, the scientists were trying to map how fruit flies respond to light by tracking changes in their movement. The agent was asked to compare the fly's forward speeds when the light was on and when it was off. The appropriate method in this case would be to calculate the on and off averages for each fly and then average them across the globe. So what the agent did as an output was to produce a very tidy file, and its final values fell within the benchmark's tolerance. So at first, everything looked fine, and it seemed like the agent was successful in the task. But when the researchers examined how it had reached the answer, they found that it had skipped the per fly calculation. So what the agent had done was to select one fly with a specially well-labeled trajectory and use that fly as a proxy for the whole group. By chance, that fly was close to the true group average, so the answer passed the benchmark. So as one researcher put it to me later on, he said that the agent was numerically right, but methodologically wrong. The goal was appropriate, the output was successful, but what had gone wrong was the way the agent interpreted and carried out that task. Its shortcut erased the variation across flies that the scientific procedure was meant to preserve. So this is the goal plan execution gap in practice. When we assign a goal to an agent, we also give it some discretion over how to accomplish that goal. Its autonomy grows when it can carry that discretion into action. But that leaves us with this question of where to draw this boundary between what is useful delegation and what is an agent's autonomy.
Sorry, I had to unmute myself. Forgive me. So Ranjit, for you, bringing up this concept of autonomy and beginning to unpack it, Margaret, I actually want to turn to you and sort of ask you to chat a bit about how your recent work intersects with this idea of agent autonomy. You've mentioned that it exists on a spectrum and that risk grows as people kind of cede control over an agent's actions. I'm wondering how you're thinking about sort of where builders should draw the boundary between useful delegation, which surely there is, and forms of autonomy that can no longer be sort of meaningfully overseen. Sort of in a second sort of side question to that, for agents that do remain within that boundary, what would users need to observe and what authority would they need to obtain to retain for oversight to be meaningful?
Yeah, there's a lot to unpack there. So first, I'll just give a bit of background that at Hugging Face, we've been working on sussing out what autonomy means technically. And one of the inspirations here is from the driving automation standard from the Society of Automobile Engineers. So you all might be familiar with this, but basically for self-driving vehicles, there's a scale of about 6 levels of an increasing autonomy, where the lower levels, the car can just help with like lateral motion, that kind of thing. Whereas at the upper levels, you can essentially just sit back and the car can drive. And so that basic standard of increasing autonomy is super relevant to how we've been developing AI agents. And so last year we put out a scale that kind of highlighted how the autonomy increases with respect to how we cede human control. And that, looking at it technically, helps kind of explain where the exact like points of pressure are in order to control agents. So at the lower levels, you have the ability for agents to just select amongst a set of pre-specified arguments for a function, right? So you know all the kinds of arguments there can be, but based on some sort of internal processing, it can decide which one is the correct one, right? At the higher levels, you start having like React agents, right? The plan, execute, observe loops. things that can be a bit more iterative, but the action space can still be externally defined by a person. Once you start getting to the higher levels of autonomy, that's when the action space can start to be enlarged by the agent itself. And when the agent itself can start to enlarge the action space, that means the tools it can operate with, it could create the tools itself at the highest level of autonomy, the different APIs that it's able to access, that kind of thing, then it starts to become really hard to foresee what it might do because you don't have the definitions for all of the possible action sequences, right? So it's at these higher levels where there's the option to extend the action space, where you need to start thinking about what are the constraints on those extensions that we should put, keeping in mind the fact that zero-day vulnerabilities are a big risk. So I don't know how many of you followed the Hugging Face hack. So AI agent hacking and autonomy is near and dear to us at Hugging Face. When we were recently hacked, we were kind of just really excited because it showed our like theory about fully autonomous agents were sort of coming to be. But basically the idea is that if you can extend your own action space beyond what might be defined by people, if you allow an agent to do that, then you can't foresee what it's going to do. So the question is, how much should that action space be predefined? And if it starts to extend, what should be put in place to make sure that that extension comes with approval from a human? And that's where you start to get at that boundary between really critical control and sort of more agent freedom of action.
And I think that actually is a really nice segue into the idea of oversight, right? And so, Samir, I'm wondering if you could talk about kind of what changes about the idea of oversight when an agent is given a high-level goal and can plan and act across connected digital environments.
Sure. Thanks, Madeleine. And so I think before I get into it, I think we have all kind of agree that oversight is a little important here. We need some human in the loop, right? As Margaret was saying, zero the exploits and all, things are getting kind of out of control. But here's sort of the interesting part, right? Like, if you look at the advertisements that are put out for agents, we see a different story, right? It's like, hey guys, sit back, relax, let the agents do everything. You go out, touch grass, do whatever, come back, task is done. You can be all creative you want. Reality, it cannot really be too far from that, right? We need humans. Users are so important to the success of AI agents, right? And companies tell you the same thing, like you're just not seeing it, right? You see this small little thing written somewhere, AI makes mistakes, double check. And what that means is that at the end of the day, it's your job as a user to identify and fix your agent's mistakes. It's your responsibility for overseeing the agent. So here's the billion-dollar question. Are today's agentic systems setting up users for success? Can users actually effectively oversee agentic systems? And sadly, as we describe in the primer, the answer is pretty much no. Effective human oversight of agents today is nearly impossible and will continue to be so unless we really understand the problem and try to change something. So let me explain what I mean and go back to Madeleine, your question about how oversight practices change when agents come into this, right? But let's start with a big question first. What if even is effective oversight? What do you mean by that? And I think we at Microsoft have been sort of grappling with human oversight concept for a while now. And one of the things we see, and we explain in the primer as well, is that across research and oversight, there are 4 key components of effective oversight that really come forward as key ingredients, if you will help a user actually perform this better. And I listed them out here, sort of knowledge, observation, control, and intervention. It's a quick definition of each of them. So knowledge, right? You don't need to be an AI expert, but you do need a working sense of what the system can do, you as in the user. Like, what is the system built for, not built for? How can it fail? Roughly how it works, right? And the goal is, if you have this knowledge, you have a good mental model, you can anticipate what can go wrong, when to look, where to look. Second is observation, right? You need to not just see what the agent has produced, but also how, why it produced that, what steps it took, what tools it used, did it make any assumptions, improvisations, why or what not, right? It's kind of is like, think of this as sense making, right? If you can't make sense of what happened, you can't really review it. Third is control. You need ways to really sort of direct the agent away from failure. Limit what it uses. Hey, don't use this tool. Don't access this file. Or don't do things this way. This is not what my company does. And if you don't have control, you are only going to be reacting to failures like firefighting mode, but you're never really going to be able to fix systemic issues or proactively kind of steer them in the right direction. And finally, fourth one, intervention. Right? You need to be able to step in, pause, roll back, revise, even shut down agents when things happen to be. Kind of what OpenAI is like, oh, shut this agent down. It's gone into Hugging Face. Right? And today, I think it's not surprising. Intervention is the most discussed and most emphasized oversized component out of the old code. Right? That's what I described earlier, right? Like users are expected to sort of intervene when needed to kind of identify and fix mistakes. Right? It's not hard to imagine that intervention relies heavily on knowledge, observation, and control, right? You cannot intervene on what you don't know enough about, on what you can't see sufficiently, or what you can't control meaningfully. But knowing, observing, and controlling agents is a pretty hard thing to do. That's kind of what the primer really deep dives into. And we have the slide here again. And I know last time I went left to right, but this time I'm going to go right to left. So on the bottom, you see the three oversight practices emerging as the most dominant forms of how people are overseeing agents. It's steering, real-time monitoring, and post-hoc auditing. Post-hoc auditing, after the fact. This is something you and I are probably most used to, right? You look at the final output, hey, is it right? Cool, it's right, let's use it. Right? This is kind of where we are. Now, this is the most talked about oversight practice across industry, across research, across policy. Right? This is the final and decisive point where human review will solve all our problems. This is very hard to do. Agents give today, I don't know if you've used them, but they give you a lot of information to look at to make this review. But just because you can sort of access information doesn't mean you can really understand it, right? So to give you an example, it's very easy for a software agent today to produce 100,000 lines of code, right? In a few hours. To review the 100,000 lines of code, it's not just those lines of code. It will give you probably 1 million more lines of information about why those 100,000 lines of code make sense. So imagine auditing that. Now, the details are dense, like what tools I use, what assumptions I made, and whatnot. And they're not all in one place, like they're scattered. As I described, sometimes you need to look at the plan. You're like, what happened? Sometimes you look at the context, the memory of what the agent did, right? And but it's too much, it's too fragmented, it's all over the place, right? It's very hard to make sense of. Right? Funny enough, the way sort of we put it in the primer is that it's the transparency is at once sort of too much and too little in this agentic system. That's kind of weird. The second practice is real-time monitoring, right? Same idea as post-hoc auditing, but kind of now happening as the agent is working, not sort of after it's done. So imagine a small early mistake happened. It can keep compounding into a failure, irreversible mistake. But if it's caught early, hey, that's good, right? So we want to kind of monitor them. And people are recognizing the importance of monitoring. And you do it by sort of, approving intermediate steps that the agent does, or kind of just, observing what's happening in terms of how it's explaining it actually. But imagine if I told you that at the end of the day, post-hoc auditing is hard. Imagine how hard that is in real time, right? You are now trying to understand fast-moving, rapidly changing information, which is happening at superhuman scale and speed in real time as the agent is doing stuff. And I'm just talking about one agent. It's so common for people to run 3 or 4 agents right now at the same time. So I can't even imagine what the context switching, task switching problem there is. Plans are changing with execution. Oh my God, context shifts constantly. And you have to kind of track everything. I'm always 10 steps behind. I don't know how anyone is really reviewing this. It's really a structural mismatch, right? Like kind of time and speed, humans and agents doesn't really match up. And we need to do something about that. And finally, last but not the least, steering, right? This is kind of emerging as a very new kind of oversight practice. We published one of the first papers that kind of empirically shows how it exists. You often think of steering as control setting. But in this way, we see that a lot of people try to sort of steer agents even before agents write a single line of code or take any action or even make a plan, right? You want to configure like, hey, don't do this, don't do that, don't access this, don't do that. Kind of hedging bets you do beforehand. Make sure that when it actually does something, it minimizes a lot of the failures I know it can do. And overall, sort of, we see that the way builders and are sort of designing and policymakers are regulating these kind of oversight and agentic systems often really don't give users the effective capacity, if you will, to actually perform this properly. Human in the loop on its own is, to be honest, not really working, and it's not going to work unless we can identify this problem, start talking about it, taking it seriously, understanding and critically understanding what's the role of humans in agentic worlds and how best humans and agents can and should collaborate to make sure disasters don't happen. Back to you, Madam.
Yeah. Thank you, Samir. I think one of the things that is so very helpful about this work and about the primer is putting a vocabulary and a way to talk about some of this work. Margaret, some of the work that you've done around autonomy, again, sort of having a way to talk about really complex things. Name them, think about them more deeply. And of course, I think there's also a really important perspective of sort of putting those concepts, which maybe we all live in a certain way, but seeing them also play out on the ground. And so, Ranjit, I want to kind of turn to you and ask you a bit about some of the field work you've been doing and what kind of meaningful oversight looks like in your field site when an agent is carrying out scientific work.
Thank you, Madeleine. I think that this question always kind of makes me think about how the description that we give to an agent changes the nature of scientific knowledge that is produced by the system. So in the primer, we kind of distinguish between an agent's working and the scientific method. So by an agent's working, we mean what an agent does to produce a result. And it can start with one plan and change course when it runs into a problem. This happens all the time. And that working may still produce a useful or correct output. But scientific method needs a lot more than this flexibility. Because scientists have to establish two things. First, why is a procedure reasonable enough to study the phenomena that they want to study? And second, how does the evidence it produces support the claim about the phenomena that they're studying? So in the primer, we use the term epistemic integrity to describe the trustworthiness of this process. How do you kind of imagine what a scientist is doing and how they can actually kind of make claims about the process that they have followed in order to study their object of inquiry in the first place. So once an agent kind of becomes a part of this research process, its working has to be open to the same kind of scientific scrutiny. So one way I've been thinking about this, to add another term to our vocabulary, is what Harry Collins has called the experimenter's regress. And I'm going to explain what this regress looks like. So the regress becomes really visible at the research frontier, where appropriate results are still unsettled. And it kind of looks something like this. So how do we know whether an experiment was performed competently? We know this by looking at its results. But then how do we know what the appropriate result of an experiment should be? We resolve this by looking at a competently performed experiment. And that kind of leads us back to the original question of how do we know that the experiment was performed competently? Any evaluation of an experiment seems to require another experiment. And that is fundamentally the regress of an experimenter. So repeating an experiment in this case does not automatically resolve this uncertainty because scientists still have to decide whether the second experiment was carried out in the way in which it makes it a valid test for the first experiment that was happening in the first place. Now, this complexity already exists in the way scientists do experiments. Now add agents to this, another layer to this regress. So think about it this way. When an agent produces a result that a scientist do not yet know how to judge, they cannot validate its working simply by checking whether the answer looks right. Its answer itself remains a part of what is uncertain. So the agent's working becomes another object of validation that needs to be verified in order to see whether the agent is actually giving us the right answer or not. So one way to actually kind of do this work is to specify more of the method before the agent begins to take actions. And this brings us back to steering, one of the oversight practices Samir talked about. So in the benchmarking lab, steering appeared in a basic design problem. How much of the scientific method should researchers put into the prompt before the agent begins? The team kind of called it the difference between a minimal prompt and a maximal prompt. So what a minimal prompt does is that it gives an agent a goal and a relevant data. It describes the desired output and leaves the agent to decide how to get to that output. Now, this exposes more of the assumptions that an agent would have to make in order for it to be able to reach from a goal to the output that is desired. And it also gives agent more discretion over choices that could change the scientific meaning of the result. A maximal prompt, on the other hand, supplies more of the method in advance. It includes intermediate steps, file conventions, helper functions, contextual details. So the agent becomes easier to guide, but at the same time, now the benchmark is doing more of the scientific work with the maximal prompt. So now if you're trying to evaluate the performance of coding agents to see whether they can work as scientists, the team started worrying about whether this might be cheating. So if you're giving an agent a maximal prompt, you're giving it much more detailed information about how to produce the right result. So, and the concern becomes that a maximal prompt could smuggle a solution into the task, and the scientifically meaningful work is currently being done upstream into the benchmark design itself. So the agent's eventual success might look more like following instructions than reasoning about the appropriate method to get the right answer. Which brings us back to the way in which Margaret described what the action space for agent should look like. The team needed to delegate enough discretion for the agent's contribution to be meaningful, but they also needed to constrain that discretion enough for the agent's autonomy to remain manageable and its work easier to benchmark. So in a way, the prompt becomes one place where the boundary between delegation and autonomy is drawn. How much of the method should a scientist specify before the agent begins? And at what point has the scientist already supplied the solution are two of the core questions to think about when we are thinking about oversight of agents, especially in the context of doing science. And these questions allow us to think more deeply about where we should draw this line between what useful delegation looks like and where should we trust the autonomy of an agent to do the task. But at the same time, in all of this, as we are drawing this line and the boundary, the responsibility for a scientific claim still remains with the researchers. They remain formally accountable while losing the visibility and authority needed to oversee the work of an agent. And this is where I would like to bring you in, Madeleine, because your work on moral crumple zones has really shaped a lot of our thinking in the primer. So, and could you say a little bit more about how moral crumple zones help us understand the gap between being held responsible for an agent's work and having the practical capacity to oversee it?
Yeah, and I just want to really truly recommend to everyone, if you haven't already, read the primer, because you also get some of these like rich ethnographic details and sort of seeing both a means to get some really interesting concepts and vocabulary on the table, and then also to explore what it looks like in practice for a specific community. This idea of moral crumple zones, I think, of course, panelists know, but for those who don't, this sort of came out of a lot of work done when I was here at Data and Society with a lot of other great collaborators that was looking at kind of how does responsibility change in the context of driverless cars. Long story short, we also began to sort of notice or see this gap in the sort of control that was being attributed to a human in a complex technological system and the responsibility that they were being given. That is to say, moral crumple zones was a way to talk about an emerging, widening, and we found very troubling gap between the control a human actually had in the context of a technical system and the responsibility that they were holding for the action. And it seems to me that is really playing out again, as you all are describing, in the context of agentic control, right? And sort of what are we really setting the human up to succeed in the control and responsibility task that we are asking of them? And I think what this conversation is pointing to is that, currently no. And this is, I think, unfortunately, a common pattern that we can see across the history of technology and automated systems. But that it is really, really urgent to kind of think about how do we sort of name this gap, this emerging gap that we're seeing, so that then we can talk about kind of solutions or mitigations, I should say, probably, because I'm not sure there are solutions. So I want to actually sort of have a couple of questions for all of you, and then we will get into audience Q&A. There are a lot of questions, so we're getting there. Don't worry. I want to ask all of you, how you think about the areas where oversight is most meaningful and what form it should take. Ranjit, you kind of began to talk a little bit about this for the scientists you work with, but I'm really curious from everyone's perspective, when you're thinking about this problem space, how do we think about what is most meaningful in an oversight, in different types of oversight contexts? Ranjit, I don't know if you want to start and then move across.
Sure. I can talk about meaningful oversight, particularly in the context of how in the sites that I basically observe and work with, it seems like a lot of attention currently is placed on post hoc auditing. And in that sense, Samir is right that we kind of tend to look at outputs more than anything else in order to actually understand what's really going on. And to some extent, this question of what does it mean to actually make sense of an output is clearly one of the ways in which a lot of people are kind of thinking through whether they can actually even understand what an agent did and why it changed strategy mid-course, if it changed the plan and stuff like that. So I think that part of what I would say as an opening for some of these conversations is one of the observations that we make in the primer, which is broadly focused on this idea of what does selective transparency look like in this case, and what do people need to know in order for them to be able to make sense of what the agent is doing and whether those actions actually are right in the context of the domain that you're in. In science, there's a lot more emphasis which is placed on method, and there's a lot of ways in which peer review and the process of kind of arriving at a result is deemed as an important part of the process. That's not necessarily the case when you're trying to book a tribal itinerary, in a way, for example. So each domain has a very different specification around what it means to actually oversee the agent, and sometimes just looking at the outputs are enough. Sometimes it is really important to think about what does it mean to actually constrain the action space for an agent so that then you can start thinking more deeply about what is it allowed to do and what is it not allowed to do. And even when it is not allowed to do something, we have seen cases that agents don't really follow instructions very well. So part of the challenge is also kind of how do you actually then, even with these limitations, create the right environment or scaffold within which an agent can work, which allows for people to actually be able to meaningfully control their actions. So I can understand why intervention becomes such an important site to think about these things. But at the same time, if we don't have the prerequisite conditions for that intervention to be possible, then we are kind of stuck in a way in this loop of figuring out who's the right person to basically be holding responsible for things.
I think that's such an important point to pull out also, that like it really, context will matter of what oversight is relevant and meaningful, and that one size is not going to fit all. Jumping contexts and getting to this idea of about sort of asking what is the agent actually doing. Margaret, I want to ask if you have some thoughts, both from your research in this area, but also some of your kind of recent experiences. How do you think about like meaningful oversight and what form it should take?
Yeah, thanks for asking that. And this is also relevant to work I've done with Samir, which I think we'll release next month. But basically, one of the things we're seeing is that people get bored of oversight, basically, right? So like, there's always this idea in development of, oh, just put a human in the loop, right? But that misses the fact that we're not actually designing to keep humans in the loop. And, anyone who's worked with coding agents or sort of any sort of agent will see that they generate a lot of stuff. Occasionally you're asked to say yes or no, and over time you just sort of start saying yes. You get sort of acquiescence bias. And there's a known effect of fatigue. And so you have a bit of a working cognitive degradation. So while you're interacting with the system, you stop being able to analyze what's happening as well as you would if you were coming to it fresh. And then over time, there's also the degradation of skills more long term, which we've seen with generative AI systems, and even some predictive AI systems like colonoscopy screenings, leading to a decrease in endoscopists' ability to see signs of cancer. So we know that automated systems are already sort of prone to degrading people's intuitions about things over time. And what we're seeing with AI agents is that in the moment, people are also feeling fatigued and their cognitive skills being degraded, in part because it's just very boring. I mean, it can be so helpful to have the output, but dealing meaningfully with the process, in between input to final output can be a real pain. And so I think one of the key ingredients that we're really missing to have meaningful oversight is how do you actually design agents to retain people's attention, to make them interested, right? To keep them thinking critically and analytically instead of just going to that sort of, system one thinking where you're like, yeah, sure, whatever, I'm not going to pay a lot of attention. And currently, that's a hugely missing gap. And there's a lot of development decisions that can be put into place. There's a lot of deployment level decisions that can be put in place, like, rotating people's oversight roles and that sort of thing. But the science isn't there. There's human computer interaction has such a beautiful long history of warning about these things. And a lot of those lessons have not actually been implemented in AI agent systems. And so that science of agent human interaction really needs to be taken seriously for there to be meaningful oversight.
Absolutely. And I think calling it in some ways like a new area of study, right? Because we also there is a long history of human factors research, which tells us that humans are very bad at taking over in highly complex information systems like quickly, right? And this is some of the work that we did in the context of driverless cars and aviation, but this feels like it's a similar but sort of uniquely different set of considerations about what does AI agent design look like. I often think about how many of us just like click OK to cookies, right? And that's essentially what the kind of agent mechanism is right now. Like just click the cookie. Samir, I want to get to, there's so many great audience questions, but I want to sort of ask if you want to add anything to the conversation that we're just having around sort of meaningful oversight.
For sure. Thanks so much, Madeleine. I think for me, it's important to understand, I think that nobody's saying that humans should review everything. I think that's the wrong approach to take here. It also defeats the purpose of why use agent. And the idea of not using agent, that's a whole different conversation. That's a possible solution too. But the important thing is that as these things progress, oversight will get selective. We want it to be selective, but we want it to be effective. We don't want humans looking over the shoulders of agents all the time, but we want them to look when it's needed. And as Margaret is saying, right, agents should be able to tell the user why you should be looking where and why. And that's not reliable right now. So that's one of the big problems, right? One thing I would say is as agents get better, people will tell you problems are going to go away because if it's highly accurate, what's the issue? But we are telling you it's not going to be 100% accurate. The only way engineering is going about making 100% accuracy is through MCPs, Model Context Protocol, basically rewiring the entire world so that agents can talk to it. And I don't think you can rewire the whole world if agents talk to it. And that's the wrong approach, right? You have to learn from failures and actually work in our worlds because we are working when they're doing our jobs. And I think I'm glad you brought up human factors, right? Because we know that there are problems there, but there are also solutions there if we somehow have made it work. Like ATCs can do a good job sometimes, most of the times, but we're not learning from that at all, right? In some ways. And I think that's part of the bigger challenge where what would it mean for oversight to be selective but actionable? I think this is a whole new science, and we really need to unpack kind of what's happening there.
And I've just been reviewing. There are a lot of questions, so many great questions. I want to apologize in advance. I think we're not going to get to all of them. But please, I also love the kind of conversation that is happening between people in the Q&A. So please continue and share resources and share knowledge with each other. I think I might try and sort of group some of these questions together. I think one sort of set of questions is actually sort of coming around like, and I think, Samir, you kind of began to get at this at the beginning of what you were saying. Like, I think in some designers' minds, they would not disagree that humans are very bad at sort of monitoring and taking over when needed. And so then their, I think, goal, they would say, is that precisely, like, let's not have humans in the loop because they can't be effectively in the loop. And that we should actually just make better agents to monitor other agents. And so I'm curious if anyone wants to kind of share their a thought or perspective on this idea of, well, we're talking about the wrong ending here, and the ending that we should be working toward is like perfecting the agents and having agents upon agents.
I can, since I already started a little bit about that, maybe I can take a quick stab and others can join in. I 100% agree. If the history of technology, science and technology studies has told us anything, is that when technology gets too advanced, the easiest thing to do is get the human out and replace it with a whole different system. We're already seeing it. It's very fashionable these days to say, I have an agent that writes code, and I have another agent that debugs the code, and I have a whole different agent that fixes that code, and so on and so forth. And then another agent, right, that pushes the code. Like everybody is like managing a team almost, right? So you're kind of becoming more of a managerial position and less of kind of doing yourself. And yes, if we go down the path, yeah. But I think my hope is, and this is kind of where a lot of the thrust of the work is, that we don't want humans to completely disappear from these pipelines. We think it's important. And how can we meaningfully keep them in? I think that's the challenge we're trying to solve. Like, of course, it's hard. But then, of course, there's some potential to technologies that we wanted to use. And I think that's kind of the balance we are trying to strike and what you do. And when I said like things like knowing, observing, controlling, and intervening, like, of course, that's hard. And the goal is not that you need to do all for all the time. The goal is that that's kind of what we think good oversight is. And some of it is being over focused, some of it is less focused. And how do we kind of balance that out in a way that's meaningful to the agent and the user? And I think that's the bigger challenge that, yeah, we should be using technologies for automated direction and stuff because they're good at it. But people don't take it seriously these days because they feel like they can just ask Claude or whatever, do it again. That's not the right way to go about doing this. We haven't even touched the environmental costs of these things. That every time we redo an action, there's a lot of damage you're doing. And of course, people are trying to make it cheaper, but redoing is not the right approach to oversight.
Yeah. Did anyone else want to add in? Otherwise, I was going to move to the next question.
Yeah, I think I'll just add in something that actually I learned from Samir, which is that scholarship in HCI and SDS have highlighted that the idea of a perfect agent is it's not something realistic, and it's also not desirable. If you want a system that's flexible, which is the goal of agents, then there's going to be potentially conflicting needs, which means that by design, flexible agents are not always going to give you the right answer. Never mind the fact that you can't have, a perfect machine learning system. And so the idea that like human oversight concerns are becoming obsolete because technology will fix it misses the point that there is no such thing as a perfect agent if they're meant to be acting like flexible agents. And then it also misses that part of human experience requires getting things wrong, making mistakes and learning from them, right? That's how we develop cognitively. And so even if we could develop systems that do things perfectly for us, we're giving away our own autonomy and our own ability to develop cognitively because we need to be able to make mistakes in order to sort of sort things out as well. So this idea of, maybe we'll just keep working on agents and everything will solve itself, I think misses the reality of both what AI agent systems are and how, human development works.
Such a great sort of technical counterpoint to how people would talk about the capabilities of agents. It's, yeah, Actually, speaking of that, I want to pull on another kind of theme in some of the questions, which was around actually anthropomorphization and talking about agents as someone writes about how, we're talking about AI agents escaped sandboxes. Of course, it's worthwhile noting that we talk about children in sandboxes, right? They band together in swarms, they leave each other notes and have conversations. We talk about Claude, which is, of course, like a traditionally male name. I'm curious if, on the one hand, there is a certain power and a certain kind of cognitive ease in talking about agents because they are doing, at some level, different types of cognitive planning and tasks. But is there a trade-off that you all think about when thinking about how to talk about agents as human-like? Does that complicate the ideas of oversight? And yeah, just kind of how do you think about this relationship between calling a thing an agent and calling humans human?
I feel really passionate about this, so I'm happy to say something if so I also really, really try and avoid anthropomorphization because what it does is it smuggles in assumptions as if they're true, right? So the words we use in AI are metaphors. It's everything from learning to intelligence, reasoning, chain of thought. These are all metaphors that we're borrowing from human mentalistic concepts. But these systems are not human, right? And so you can think that they have cognition, but it's not animal cognition because it's not an animal, right? But when we're using these terms, we start to implicitly imbue them with our understanding of what happens with animals and with humans, right? So we fill in the blanks of what we don't understand with our conceptions of how things work for humans and for animals. And that means that we have blind spots because we can't see how our assumptions are shaping everything we're understanding. And it also has really significant legal repercussions too. So, for example, the concept of learning has been argued in court to be basically identical to what kids do when they read in the library. And you can make that argument if you call it learning, right? Because it's the same word, but not because it's technically the same, right? It's not, these systems aren't made on protein substrate, they're made on silicone, right? So the anthropomorphization issue is very helpful for explaining basic concepts, but the metaphor stops being a metaphor. And that's where we get into issues of having blind spots in how these systems actually work and what we should be able to foresee and think about. And in light of that, that's why I specifically say autonomy and not agency, because agency implies moral agency. And wow, that is a lot to imply, right? So I think that there's been a lot of really useful critical work on the meanings of the term automation, autonomy, and agency. In the agency realm, you get into a lot of really tough philosophical discussions about what does it mean for something to have agency and what does this mean for like legal personhood. But we don't need to use those terms because they are just metaphors for something that isn't human and isn't an animal. So, I do use some anthropomorphism. I mean, I work in tech. You have to anthropomorphize if you work in tech. No one will listen to you if you don't. But I do try and do it sparingly because it's too easy to fold in assumptions that you don't even realize that you're making based on your preconceived notions of what these things mean in terms of people. So I'm very passionate.
Oh, I love it. I love it. Anyone else?
Plus one to that quickly, Margaret. 100% agree, and I think such an important point that to not kind of confuse the two or not. Just want to add a little bit to that, which is more of not a counterpoint or anything, but kind of a parallel to it. You see tech leaders anthropomorphizing left, right, and center. Right? Left, right, and center. There's not careful with the terminology at all. We are very careful with terminology. I think and it's true that we shouldn't be anthropomorphizing. One of the things that's happening is somehow our vocabulary has been reclaimed by people in a very different light. They talk about intelligence, consciousness, with a complete disregard to the history of those terms. And yes, we can stop using it because that's not the right way, but we also need to reclaim that vocabulary. And reclaiming it means using it in the right manner over and over again to be like, this is not what you mean, so that this has a history. And I think part of some of the work is what we have been doing is to be like, hey, we will talk about safety, we will talk about responsibility, we will talk about accountability and whatever. Yes, moral order, because you think your things have agency. Well, they need to be moral to have agency. Well, there we go. That's an engineering problem. Go solve it, right? And I think some of the power move has to be shifted because we have been just too careful using our terms, and they have just been throwing it around and whatever sticks on the wall for money. And I think that's not the right way to do it. So plus one to what Meg is saying, and I think there's a lot of reclaiming work we need to do, and that's part of the vocabulary thing that Madeleine mentioned earlier as well.
Looking at the clock, there are so many amazing questions. I truly am. I wish that this conversation could go on a bit longer. I guess I want to kind of add a final question to everyone, and I would ask you to answer quickly because we are sort of running out of time. I think we have talked a lot about kind of agents sort of on their own terms in some ways, and I wonder sort of if you all, for people, either policymakers, technologists, other people sort of coming to this conversation, what would you want them to kind of take away from this conversation? How do you think about the future that you are kind of wanting to bring into being, and what can people do? Meg, I'll start with you.
Yeah, I mean, I would say one of the keys here is just to be really clear on what we're talking about technically, because it is, I mean, bringing in a lot of the stuff that we've chatted about throughout this session. It is really easy to just sort of rely on our human intuitions of how humans act. But there are very clear technical underpinnings of everything that you can see and observe. And so when we're talking about governance, when we're talking about regulation, I think it's really important to make sure that we ground on what is actually happening technically. And if that's not clear, from an organization, then incentivize people to be more clear about it, right? That's where like interpretability research comes in and that sort of thing. So yeah, ground on the technical, even as you try and figure out how it is human-like, or, how it's interacting like a swarm or whatever it is, like ground on what it actually means technically.
Ranjit, ask you to go next.
So I think that, so the starting point of what we are trying to do with the primer and the argument that we want to make here is that our standard policy response of basically ensuring that there's a human in the loop and that resolves the problem of oversight is not going to solve the problems that AI agents raise. And that is a fundamental challenge of thinking about what broadly we should be kind of imagining what a policy response in this space should look like. So that requires us to think about two things at the same time. One is, what are the ways in which we can use these systems when we don't trust them? And what is the right way of imagining what that mistrust kind of looks like? How do we actually make that a part of the policy work that we are doing in this space, that, these systems fundamentally cannot be trusted, but that doesn't mean that they can't be used. And there's a difference between them that we need to think more deeply about. Particularly because, our starting assumption is that we need to be able to trust the system in order to be able to use it. But, mistrust is an equally powerful organizing principle of societies. And, it's not necessary for us to be trusting systems for us to be able to use them. The second thing that I want to say is that there is a way by which part of this work seems to be mostly about, what is the right automatic loop that I can create, which will go on top of whatever the agent is doing, so that, oversight is solved by more automation in a way. And that lends itself into a particular socio-technical problem where even that particular loop that you're setting up, which is automatically looking at what an agent is doing, fundamentally relies on decomposing a task that you initially had in mind into specific things that you can actually look for, which means effectively what you're doing is that you're displacing that responsibility rather than actually solving it. So in many ways, scalable oversight kind of repeats the problem, but makes it more hidden and diffused rather than actually resolving it.
Amazing points. Samir.
A lot of good already has been said, but I'll say one last thing if you're talking about policy specifically, I think we are in that world where the discourse currently is about that, okay, all this, you know what all this means? All this means is humans are really bad at overseeing agents. Right? It can quickly devolve to that point. Right? I want to flip the question, and the question that I think policymakers should be asking that, yes, humans are bad at overseeing. To be honest, current agents are very bad at being overseen. Why are we not talking about that? So yeah, I'm bad, but you aren't really good either of being overseen. So what can you do to make it come to my, because at the end of the day, I am the customer, right? And I think that's a simple question. Like when we flip that around, the policy question isn't simply about where should the human go, what should it do, and whatnot. It's about, okay, what's the responsibility of deployers, organizations building these tools to make it such that users can actually step in and do this kind of work. I think, yeah, I'm bad, but you aren't really good either, man. And that's kind of my response to that.
I love that. I think that's an amazing place to end on. I think, you know, there's obviously many more discussions that need to be had. Would love to continue this discussion. But obviously, you know, I think what today's conversation is really sort of laid out is a vocabulary for talking about how placing a human in the loop is not an end. It's not an answer. It raises a whole other set of questions around what is meaningful oversight, and how does it vary by domain. You know, very, very interesting context of the scientific community that Ranjit has been working on. We've also touched on other examples, and I think really tried to sort of open up a different set of questions for policymakers, for advocates working in this space around, you know, as agents become organizational infrastructure, not taking that as a given, but also acknowledging the forces that are pushing it forward. What do we do, right? And how do we keep this idea of challenging human oversight and challenging responsibility of deployers and of those developing these systems? How do we sort of demand that they begin to think through some of the problems that we are seeing as well? And how do we ultimately think about these bigger questions of responsibility that we all share, right? That sort of occur at different moments of research, development, deployment, and integration. This has been truly the delight of my week. Thank you. Thank you, Ranjit, Samir, and Margaret for joining us. Thank you, Rigo and the Data and Society team for having us. Thank you to all of you who joined and submitted awesome questions. I'm sorry we couldn't get to all of them. I'm sure you can find all of these people on insert your social network of choice. The Oversight Fallacy is available on the Data and Society website. Everyone should go download it right now, send it to your favorite friend and lawmaker. Yeah, the links are shared in the chat. Thank you for being with us today. Thank you all for the conversation. Have a great afternoon or morning, wherever you are.
Thank you.
Thank you all.